Hello, my name is Harteet Singh, and I was trying to teach the chemistry of the atom to students of ninth grade and 8th grade. But I found that in the textbook, the periodic table had been removed. It has been introduced in the 11th grade, perhaps because of the complexity. So I thought I'll make a video to show you a reduced periodic table so that you can get the fundamental concepts. So here we go. So if you see, this is the normal image of an atom where you have this nucleus and you have lots of orbits around it. And the periodic table of elements looks like this. It's got these 7 rows and 100 and I don't know how many elements. So this is very, very, very confusing. So I thought I'll just focus on the top 3 rows and observe. Along with that, the potassium and calcium, which brings us to the first 20 elements. And observe that there is nothing between beryllium and boron, magnesium and aluminum. So I figured I'd rename those columns as 3A, 4A, 5A, 6A, 7A, and 8A, which will correct at the end, as you will see. Therefore, this is the reduced periodic table. So if you look at the columns, you have hydrogen, whose symbol is H and the atomic number is 1. So accordingly, we can go and see the rest. So if you go all the way to the right, noble gases, you see helium, the He, 2. Then you turn around and come to alkali metals again, lithium, Li, 3, beryllium, Be, 4, and so on and so on. So we will now dive in to understand how it works. So the closest thing to understand what orbits looks like is to imagine the Earth and the Moon. So the Moon is rotating around the Earth in an orbit. So now let's look at the hydrogen atom. There's a nucleus in the middle which has 1 proton, and in orbit around it you have an electron. And the shell that this revolves around is known as the shell number K, which is the first orbital or the first energy level. The number of protons is always equal to the number of electrons, and the proton weighs 10 to the power minus 27 kg, and the electron weighs about 2,000s less than the proton. So if you were to see, imagine a proton is the size of a football, then the atom is the size of the football field. So that's the ratio. So now let's go to helium. So another proton has been added into the nucleus, and a second electron has been inserted into the same shell, the same orbital. So that means now the shell K is stable, which I will explain to you at the end what that means. So now when we want to come in and introduce a third electron, lithium, so a new orbital opens, which is known as the shell L, a second energy level, where you have 1 electron. So inside the previous 2 electrons are still rotating. This one is introduced as a new orbital, and 1 more proton has been added to the nucleus. The number of protons always equals the number of electrons. When beryllium comes along, a 4th electron is added, a proton as well. And when boron comes, a 5th electron is added along with the proton. Carbon comes along, whose atomic weight is 6. Those 6 are comprised of 6 protons in the nucleus and 2 electrons in the inner shell, shell 1, and 4 electrons in the outer shell. And nitrogen requires an atomic weight of 7, so there's a 7th electron. Now, the 7th electron attaches to the first electron, and they're both spinning in the same orbit as in the second shell. Oxygen comes along and a new electron attaches to the second electron. So now we have 2 inside, 6 outside. Now you got to fluorine, whose atomic weight is 9. So we have 9 protons, and the 9th electron attaches in the second shell. And you come to neon, which has 10 protons in the nucleus, and the 10th electron attaches to the electron. So now this is stable because it has got 8 electrons. So there is no more vacancy in this second orbit. So now when you come to sodium, which is atomic weight 11, the 11th electron opens up a third orbital, which is known as the shell M. And there's obviously always a matching number of protons to the electrons. So as you will see, they keep increasing in the nucleus. But a new orbit opens up for the 11th electron. And when magnesium requires one more electron, it adds into the third orbit. Aluminum is an atomic weight of 13. So 13, observe, 2 in the middle, 2 in the first, 8 in the second, 3 in the third. Silicon has a 4th atom, 14th electron added into the third orbit, and 14 protons in the nucleus. Phosphorus now attaches its electron to the first one, which is the 15th electron, because its atomic weight is 15. Sulfur attaches a 16th electron. Chlorine attaches a 17th electron. And argon attaches the 18th electron. So now you observe that there are 8 electrons in this shell. So shell M is now stable. It has no desire to receive any electrons or give any electrons, so it is closed. Now when potassium comes along and says my atomic weight is 19, please allow me in, they say no. One more orbit will be open for you. The 4th orbit opens, and you can see the first electron of potassium. So that's the 19th electron and 19 protons to match. And then the calcium atomic weight is 20. So a second electron attaches in the 4th orbit. So we'll stop here, and this is for you to understand the atomic structure. So there's an octet rule which you must remember, and that is that atoms attempt to acquire the stable electronic state of a noble gas, which is usually 8 valence electrons. While it is 2 for helium, it's 8 for the others. And if you have a molecule, they share electrons, and an ion gains or loses electrons, as we'll discuss in the next chapter. So now let's go look at the same periodic table again. Observe that the top row I have now renamed to valence electrons, 1, 2, 3, 4, 5, 6, 7, and 8. And because the noble gases have 8, helium, neon, argon, these are all stable. Therefore, these are known as noble gases, inert gases. They don't react at all. And observe that in the first row, you have only 2. And lithium is now in the shell L, which goes across to neon. And then you open it up for sodium, all the way to argon, and potassium to calcium. Another thing I'd like to draw your attention is, observe that hydrogen plus 2 comes to lithium, but lithium plus 8 comes to 11 because it is in the next shell. 11 plus 8 comes to potassium, which is 19. Similarly, beryllium is 4 plus 8, 12 plus 8, 20. Boron 5 plus 8, 13. Carbon 6 plus 8, 14. All the way through chlorine 9, fluorine 9, chlorine 17, and then neon and argon. All of them have a difference of 8 because of the shell.